Hey guys, welcome back to E&M. I hope to finish chapter 5 here and assign some final problems. And it looks like we need to have an assessment, just chapter 5. It'll probably be a week from Tuesday. So it'll be in class. Dr. Habdas should be able to proctor. And let's work on that. So a week from Tuesday, I think the Tuesday before Thanksgiving, we'll have an assessment on chapter 5. Okay, so what I want to do in this discussion is to redo what hopefully you did back in chapter 3 on the electric potential. And hopefully you remember the multipole expansion. Very important, actually. And we're going to redo that derivation. This time, however, with the magnetic vector potential. I ask that you know the derivation, you know how to do it, you can derive it, you understand it. And so I'm going to do it here, make some comments, some comments that are not in the text, and I'm also going to point out I guess a misinterpretation by Griffiths in the vector potential expansion. And so it's a subtlety, but I want to point it out to you. It's rare that Griffiths makes an interpretational error, but I will point it out. So anyway, let's get started. So we're going to have, we're just going to have a current distribution. It has a steady current. Need a coordinate system. And that's the origin, X, Y, and Z. And really what we want to know here is we want to know what the vector potential is out here at some point P. And you know our nomenclature, right? So this will be some vector R. R prime will be from the origin to some field point. So this will be some dl prime, which will be equal to a dr prime. And from the field point, or source point rather, to the field point is script r, where script r is equal to r minus r prime. Okay, and we're going to look at this. We're going to look at this in the regime where r is much greater than r prime. We could also, we could also look at the regime where r is much less than r prime. And so we're going to do the derivation for this condition. However, I'm going to ask you to think about this, and it's not hard if you just think symmetry, and also want you to think how you would handle the boundary where r is neither much greater nor much less than r prime, in which case these sort of multipole expansions don't work. So anyway, but let's get started. And so we know that the vector potential is going to be equal to mu naught times the steady current I over 4 pi. The integral around the current distribution, this will be dl prime over script r. Now we're going to play the same game that you guys played back in chapter 3. and we're going to look for an expansion of 1 over r. And actually, you remember, it actually turns out to be the Legendre polynomials, which is actually quite magical, actually, if you really think about it. So, so again, we're going to redo that derivation. Again, it's a derivation that I ask you to know. The Legendre polynomials come up all the time in physics. Obviously, here in E&M, they came up when solving for the electric field using Laplace's equation. They come up in quantum mechanics and solving the Schrodinger equation. Actually, in that context, they come up as the associated Legendre functions. So, but a certain acquaintance with these is definitely something you should have in your toolbox. Okay, so we're going to use the law of cosines. So the law of cosines, which says that script r squared is going to be r squared plus r prime squared minus 2r prime cosine of alpha, where alpha is this included angle here. That's alpha. Okay, I'm going to factor out. I'm going to factor out an r squared. So this would be r squared. This is 1 plus r prime over r squared minus 2 r prime over r cosine of alpha. All right, and then I'm going to play with this. I'm going to factor out an r prime over r. It's going to be 1 minus, I'm sorry, it's going to be r prime over r minus 2 cosine of alpha. I'm going to call this epsilon. Okay, so then that script r squared is going to be r squared 1 plus epsilon. R then is going to be r 1 plus epsilon to the 1/2 power. 1 over script r then is going to be 1 over r 1 plus epsilon to the negative 1/2. Now for r prime, much less than r, then epsilon is going to be much less than 1. And then so we can use the binomial expansion, which really just is a Maclaurin series expansion. And so we can write 1 over script r then. It's going to be 1 over r. This is going to be 1 minus 1/2 epsilon plus 3/8 epsilon squared minus 5/16 epsilon cubed plus higher order terms in epsilon. Okay, so what we're going to do now is plug back in. We'll plug back in for epsilon. And so we're going to have 1 over a script r is going to be 1 over r. This will be 1 minus 1/2 r prime over r prime over r minus 2 cosine of alpha. This will be plus 3/8 r prime over r This will be r prime over r minus 2 cosine of alpha squared. This will be minus 5/16. Oh, and this is squared, by the way. R prime over r cubed. This will be r prime over r minus 2 cosine of alpha cubed, okay, plus higher order terms, okay? So now, what we're going to do is, let's try to clean this up and collect like powers of r prime over r, okay? So let me just, this should be, I want you to get buggered up here. This is r prime, okay? And this is r prime. A little sloppy here, okay? So let's do that now. So that 1 over script r is going to be 1 over r. This is going to be 1 plus r prime over r. Actually, that's going to be, yes, this is minus 1/2 times a negative. So it's going to be, cosine of alpha. All right. So then that's that. That's going to be then minus 1/2 r prime over r squared, right? And that takes care of this, all right? So then let's work with the second line. That's going to be then plus 3/8. It's going to be r prime over r. This is going to be squared times now r prime over r squared minus 2 r prime over r 2 cosine of alpha plus 4 cosine of alpha squared. Okay. Maybe I'll play this game just so we can keep brackets and parentheses in order. All right, and then we're going to have minus 5/16, right? R prime over r cubed. And then first term's going to be obviously r prime over r cubed. And then descending order of r prime over r. And then the last term in that will be -8, right, cosine cubed of alpha. And then that'll be plus higher order terms, okay? So now, right, we can I guess I should most exactly, right, put this parenthesis, this brace out here, so that then 1 over script r is going to be 1 plus r prime over r cosine of alpha, and then it's going to be plus 3/2 r prime over r squared cosine squared of alpha minus 1/2 r prime over r squared. And then this is going to be plus 5/2 r prime over r cubed cosine cubed of alpha minus 3/2 r prime over r cubed cosine of alpha. Okay, and then plus, I want to, let's see, yeah, we'll do this, and then plus higher order terms. Okay, so what we have now here is, right, so this, these are the terms in r prime over r squared, right? These are the terms in r prime over r cubed. Okay, this is really to the first power, okay? And this would be to the 0 power, this first term. So then let's collect all these and clean these up a little bit. So then 1 over r, we 1 plus r prime over r cosine of alpha plus r prime over r squared. And then this is going to be then 3 cosine squared of alpha minus 1 over 2. And then this is going to be plus r prime over r cubed. And then this is going to be times 5 cosine cubed of alpha minus 3 cosine of alpha over 2. And then plus higher order terms. And I think I've forgotten 1 over r. Here, this would be 1 over r. Okay, beautiful. So we begin to recognize now that the Legendre polynomials P0 cosine of alpha is equal to 1. P1 cosine of alpha is equal to the cosine of alpha. P2 cosine of alpha is going to be 3 cosine squared of alpha minus 1 over 2. And P3 cosine of alpha is going to be 5 cosine cubed of alpha minus 3 cosine of alpha over 2. So even just taking it out just this far gives us the first 4 Legendre polynomials. Okay, so these are the famous, right, Legendre polynomials. Okay, and so now what we can do is we can write, right, we can write now 1 over script r as 1 over r, the summation, n equals 0 to infinity, r prime over r to the n power, piece of n, cosine of alpha. Okay, so I'm going to end this piece right here, and then we're going to pick it up. All right, so we have to recall that a sub r, which is now mu 0 times I over 4 pi, integral now of dl prime over script r. And so now we're gonna put this. Ooh, whoa, what happens? We're gonna put this into here and mess around with that a little bit. Okay, but for right now, this module is over. Okay, enjoy your evening. Take care, people. Bye.